Good afternoon, everybody. This is Amit Rustagi, and I'm architect with eBay Marketplaces. Today, I'm presenting um, the analytical solution applications for the eBay Marketplaces and how we effectively use Java for scalability and performance. So, I work on the big data applications. I'm responsible for the design and strategy of analytical solutions apps and primarily tracking experimentation and personalization. Before eBay, I used to work for Yahoo and I was architect for the data applications too. So it's almost 10 years I've been working on big data applications. Before we move further into the presentation, one disclaimer: this presentation is not about the analysis or the storage or the computation of the big data. Rather, this presentation is going to go and touch areas maybe majority of you may not even heard of. And this is about the data generation and the data capture. So just doing a quick check, how many of you are from analytics? Good. Looking at the agenda, I will be doing an overview of the analytics apps at eBay. I will be walking over the challenges and the opportunities. And then we talk about the best practices. And while covering the best practices, I will be going over the design patterns. And I'm referring to the Java design patterns. How do we leverage a certain Java design patterns when we architect and design these analytical apps or the solutions which primarily track, use for experimentation and personalization. And at the end, I will cover for some of those things anybody should watch for who is using Java for creating a similar set of applications. Let's talk about takeaways. So takeaways from this session will be applying Java design patterns when developing analytics applications, performance and scalability considerations for the analytic applications built with Java, and as I said, what sort of things you should watch out when building performance analytics applications with Java. What's eBay? So how many of you use eBay? Very good crowd. So eBay is one of the largest online marketplace on the internet today, serving 100 plus millions of users. And with this marketplace, we have two offerings. One we call the auction, which is our very initial product. And another offering is what we call buy it now, where you go and commit to an item and you buy it immediately. While for the auction, you have to basically bid on an item, and depending on when you win the bid, you will get the item. So the number of items listed on eBay and the selling these items across different channels. And when I will go into details, actually, what do I mean by these channels, makes analytical a very challenging propositions for this level of scales. So as I said, so the scale I'm talking about is 100 plus millions of users. We have 300 plus millions item at any given point on eBay for sale. We have several thousands of Java application servers and thousands of database instances. So as most of you know that eBay is powered by Oracle. So eBay sites, all our transactions that are powered by Oracle. So the site is got very high reliability. So which means it has to be up 24/7 and 365 days in a year. As I said in the beginning, this particular presentation is not about computation or the analysis of the data, which majority of the big data session focuses on, like how to use Hadoop, what the right storage model. So this is very different. So in this particular slide, this is like an analytics one-on-one. And in any traditional analytics architecture, there are several layers. So the top layer is the talk about the data storage, which is storing your structured as well as your unstructured data. How do you collect all the data? It means you are doing data processing, MapReduce framework for organizing that massive amount of data. Then there is a data access layer, which is some low and high level interfaces for accessing the data. Data management, how do you organize the data once you have it? Some workflow, some coordination, and then finally a set of business tools for accessing the data. And these business tools could be some reporting tools like MicroStrategy, Tableau, or some other reporting tool, or you could be running some predictive analytics or doing some data mining on the data. So that's what we call the deciding layer. So if we look at this traditional architecture, so I have created a box on the top, what I call the missing layer. And this is the layer where the whole discussion will be focused on. So for any website, so because eBay is it's a high high traffic e-commerce site, so I'm going to focus on purely from any website which gets a really high web traffic. So the missing layer really means how do you instrument those sites? How do you instrument some of the analytical application right into the core of the application server itself? So you can think actually in on any fine day, eBay gets like some hundreds of millions of events. When I say events, these events could be when the users comes to eBay, they are doing the page views, they are viewing the items, they are bidding the items. So a lot of activities happening on the site. Those activity is about creating some transaction in the databases. Those activities also creating some logs, and what we call them or refer them as a behavioral logs, right? So at such large volume, how do you instrument those sites actually to collect the data? So we have three products around them, what we call them tracking, experimentation, and personalization. So I will go in details actually within each of these products. And these are the products which form the missing layer, and all the data that gets collected, that gets generated, gets stored into the data storage layer. So the first product is the tracking. Tracking is the product which tracks the path of the user which enters through any channel we support. And eBay support different channels. So being one of the largest e-commerce site, the majority of the traffic we get through direct traffic, what we refer as to direct traffic. Direct traffic means the visitors go to the browsers, they type www.ebay.com, and they are onto eBay, they are viewing the site, creating the on the data sides, events are being logged. A significant amount of traffic is also generated through lot many other channels, which is affiliates. Like we have a eBay partner network, so you could be you can become a eBay affiliate, and you could be directing traffic to eBay, and you get paid for directing the traffic. So all these channels, each of them, like whether it's a direct traffic, it's an affiliate, natural search. Natural search is you go to any of the search engine, you type for an item like iPhone, iPad, MacBook, you get a bunch of results. The results on the left hand side called the algorithmic results. On the right hand side, you get the paid search results. So eBay cares about both of them. So on the paid search side, that decides how much marketing spend we need to allocate on the paid search, because all the traffic that gets directed from all these search engines through the paid search listings, basically we need to track and see that how much of that is getting converted. So each and every conversion that happens on the eBay side, we do have the capability to basically correlate that conversion right to the source the event originated from, like from any of the channel. Like, so one of the direct traffic could be from the mobile apps. So even for the direct traffic, we have like two sub channels. We have the eBay web app, and we have in fact, there are several of them. It's like we have web app, we have mobile web, like supported onto the browsers on a mobile device, and then we have the native apps supported on the different platforms like iPhone, BlackBerry, Android devices. So all those contribute to the direct traffic. Affiliates, big business, natural search, as mentioned. So we do spend a lot of money in the SEO optimization. Like when somebody is searching, we make sure that basically any item which is listed, and if you are searching on a specific keyword, those items should show up higher onto the search results. So all that is done by the tracking. Social media, we know that like Facebook adoption basically has gone to a stage where it is like into everybody's hand. Like majority of us, we go to Facebook, we are consuming the update from other, we are updating our statuses. So eBay is very integrated into all the possible social media, whether it's a Twitter, whether it's a Facebook. So if you are like a eBay customer and you are viewing an item, you can share the items on any of the social media sites. We do have portals. Portals is, again, it's a eBay specific, some like a mini site of things, very seasonal, and they also direct the traffic. So besides all these channels, then another two channels are the marketing emails and the site emails. Marketing emails are the emails which are sent by eBay, and that's based on like certain data analysis the eBay do based on your activity, because for email, we know the user ID, and for that user ID, eBay knows basically what kind of interaction this user has done, what kind of purchases he has done, and maybe the user was never converted. So keeping all that in mind, targeted emails are sent using marketing emails. And site emails, very similar concept, but site emails is more around like when you are transacting with eBay, then if you lose a bid on an item, if your bid is, for example, if you listed an item and then your listing is about to expire. So we do keep the user informed on a continuous basis, basically when it is required, so that user can go and take an appropriate action. So given all this, you guys can imagine how difficult or like complicated that means the whole traffic tracking infrastructure is, because we have to track a lot and we need to attribute it to the right source, and we need to do it right at the part of the request. So if we look at the overall request response model, the user goes to opens a browser, they could be going to a search engine, could be going to eBay or to the partner traffic or to the portal. The moment it hit the eBay site, at some point, we have only few milliseconds actually to track that request. And during those few milliseconds, we track the user activity, which is around all the behavioral activity. Also, we do experimentation. That's the next topic I'm going to talk about. And also, we do the personalization. So within those few milliseconds, we successfully track, experiment, as well as do the personalization for the user. So which is quite daunting and very challenging task when we talk about the scaling and efficiency, and as well as the performance aspect of any given request response model. Experimentation. Anybody familiar with A/B testing or experimentation? So experimentation is like for any website who wants to test out some changes. And for an e-commerce site like eBay, we are always testing one or the other changes. And the way we test it is we allocate a percentage of the traffic to those new changes. And the way that works is user goes to the eBay site, we find out who the user is, and then the request passes through the experimentation platform, which is again part of our app server core. So each of these modules, the tracking, experimentation, personalization, you can think of it's a part of the analytics framework that very tightly integrated into our app server, which is you can call the core kernel. So all these components are kind of an extension to our core kernel, and when a request comes in, it passes through all these core kernel components, tracking, experimentation, and personalization. So user goes to the site, experimentation platform identifies the user, then the experimentation platform is basically identifying what treatment should I serve to this user, depending on what has been configured within the experimentation platform. And then also depends on what are the experiments basically live on the system. So we do support like a lot of experiment types. So it figures out actually. And all that is done based on the user ID. So user ID is nothing but it's a persistent cookie. So every time you go to a site, a persistent cookie is created. And persistent cookie is a very mandatory or very critical piece of information, because all your information, whether it's a tracking, experimentation, personalization, all activities depending on this user identifier. So with that, response gets prepared, application serves the correct experience to the user based on the treatment. Those were given by the experimentation platform, and then user experience is logged, and then experimentation platform is again dependent on the tracking. So there is some twist here basically. So we have a tracking platform, and then the other platforms like experimentation, when the request comes in, right? So you can think basically the very first thing that happens, it creates a tracking object, and then there are a lot many other things that's happening, like it goes and creates an experimentation object. There is a personalization that's happening, and at the end of the request, at the end of the response, anything which we want to track, all these other subcomponents, they keep on writing to the tracking object. So it's a context. It's a context in the memory. It's an object, and each of those they keep on writing. And once the response is served, we take that object, we flush it out, and all the data is being logged. So what is personalization? So personalization is, again, it's about knowing the user and serving to the taste of that user needs. So at eBay, we have a pretty robust personalization platform. So we have a platform where we can identify the user across several eBay adjacencies. So the way eBay operates is we have eBay marketplaces, which is responsible which is our online buying and selling platform. We have a unit called PayPal, and we have a unit called STC, which is shopping.com, which is a shopping comparison as well as a distributed commerce engine. And we have a StubHub. So each of them, they are kind of a vertical. They specialize in a given market area. Like PayPal is the payment leader, eBay is the marketplace leader, StubHub is into the online ticketing, and shopping.com is going into the distributed commerce model. So if we could personalize the user based on their cross activity, we can leverage and basically a lot of user activity when they move from one eBay site to the another user site. So how do we do that? We use personalization for that. So eBay does see an opportunity to actually customize this information, which we are collecting in the real time, as I mentioned actually. So all this information, so you go to an eBay site, you are viewing the item, immediately you will see actually appearing on the same page all those items viewed. So it's a very common feature actually exists on all the large e-commerce site, the last items viewed by you. So that is a component that is served by the personalization module. So what it is doing is, as you are viewing it, all those viewing activity gets written to the personalization, and also at the same time, those pages are reading, and by making a call as part of the request response flow, they read that information, and then basically it is served. So same thing, you query for a given item, so your last queries, everything served through the personalization platform. Recommendation served through the personalization platform. So personalization definitely helps because it helps in delivering the targeting content. Personalization also helps basically for reducing the noise and avoiding the information overload on the users, because we are able to identify the users and we can serve very, very targeted information to these users. So we talked about the three applications: tracking, experimentation, and personalization. Let's talk about the challenges we have in these three applications. The foremost challenge: capturing the most important data as it happens. what we are talking about is the capturing the activity in the real time, whether it's a tracking, whether when you are experimenting, you want to track the data, and scalability. So as I said, so one of the problem is because we are part of the core kernel component. So even though we don't have to think so much about the scalability, but performance is a very, very important concept for us. The reason being because we're tightly integrated into the core kernel. So all the code we are writing, it needs to return back the response within the few milliseconds, and we can't do any redundant activity as part of any of that request response model. So performance, it's a very, very critical factor. And the way I have seen things, actually, performance being so critical, performance can affect your scalability. So think about, you made some changes in any of these three modules, and something which used to take only 2 milliseconds, now taking 10 milliseconds. So what will happen? So on your application server, which has capability of serving millions of requests, all those application server will scale down. The reason is because your overall response time has gone up by like 5x. So request will start stacking up depending on like whether you have sufficient hardware to actually serve all those requests. You will see like a scalability issue on the side. So performance can result into scalability. Performance is very, very important. Means scalability, yes, you need to have sufficient amount of hardware, sufficient scale out so that you can serve all that request, but performance is very, very critical. Cost effectiveness, very critical component. Why? Because all the things we do, we could have gone for some third party. So today we are living in the era of big data. So many startups have come out. Even like here there were a lot of sessions around big data, and so many companies have come up with this idea of basically how do we capture the real-time data, how do we process the real-time data, and how do we store, and how do we even do the predictive analytics, everything in real time. So not going with not going with a solution which is off the shelf, and building an effective solution from scratch just by using our internal skills. It's a very cost-effective solution, and that's a challenge. Means how many times, basically, to what extent we need to do. And again, on the performance side, our SLAs, basically, we are living in a kind of a tight boundary because we cannot change the response time. Functionality keeps on getting added. Like if you compare an eBay page from now to like it used to be like 5 years ago, the page is kind of sophisticated compared to where it used to 5 years ago. So, and same with number of applications. Like mobile was not that widely adopted 5 years ago, but today there's a lot of mobile activity. And the way we have created these applications, as I said, because we do care about all these channels, everything has to flow through at one point. Otherwise, it's very difficult actually to have like a centralized control or a centralized machinery to serve the three critical components. So let's go into the details of each of those challenges. Data capture challenges. As I said, real-time data capture means it's a challenge for us. So with the real-time data capture, what we also get for free is collecting the data with the quality more quickly. So we have basically means when we are collecting the data, means in certain cases you need to compromise on the data, but certain basic things like filtering out robots, filtering out any other invalid traffic, that has to be done. So collecting the quality data is very, very important, because for all these systems you don't want to serve the requests which are invalid. And on the top of all that, you have the increased demand within your data consumers. So at any company, like even I used to be at Yahoo, go to any end user and ask them actually, like, how soon you need the data, what's the latency you are looking for, believe me, whether they need the real time or not, their default response will be real time. So scalability challenges. Over a period of time, we have seen a pretty strong organic growth in the user base, and mobile has added to this to a lot, and which is more applications. So far eBay applications been downloaded, like there was a news in the press recently, like 100 million downloads have happened for the eBay application, like mobile native apps, which is again a lot of users who are not eBay users. They created their accounts, organic user base, and of course over a period of time, now using eBay on the native device, it's very easy. You just open the app, you bid on a certain item, you view it, it's just a click away, which has resulted into the increased usage. So with all these things, the overall traffic, overall activity has increased significantly, and which at the end results into scalability challenges. Performance challenges. As I said, anything we do, we are doing as part of the request response flow. So we live within very consistent SLAs. We have only few milliseconds to track, to experiment, to personalize, and those SLAs will remain same no matter how much complexity, how many applications we add. Those SLAs need to remain same, because eBay's overall response time for the site, we are going to maintain the same way. Redundant processing. So this is a performance challenge, because being such a complex site, so many groups, so many developers, it's very actually hard to like interact. And sometimes basically what happens is two people may end up in doing the same thing, and which results into the redundant processing, and finally it show up as a performance redundant performance, because something that should have happened only once, or some of the object which should have been initialized once, happen multiple times. When to process, related to very similar to redundant processing. So if we look at this whole request response model, when a request is received by the by the app server, lot of things happen. Like these three components, lot of activities happening in these three, but that's not the only thing. We haven't even talked about the application, the applications, and the variety of application. Each of those applications is basically doing very complex application logic, and some of that logic could overlap actually for the work that we've been doing in the tracking, experimentation, and personalization. So when to process that logic sometimes created the performance challenges, because something that could be deferred or can wait, why to do it at what point. Cost effectiveness challenges. Huge infrastructure cost involved, because it's a very large e-commerce site. There's a software cost, and then there's an ongoing maintenance cost. So any changes you make, any decisions you make around the software stack, any decisions you make around the number of applications, number of users that we will be able to support, will have a cost impact, whether it's related to scalability, whether it's related to getting a software off the shelf, or could be related to the making some of those changes, which could in a long term result into a very high ongoing maintenance cost. So we talked about applications, we talked about the challenges. What do I do now? Time to get back to the basics. So when I joined eBay, means I joined as an architect. So the very first thing I did, I took a holistic view of all the things that happens as part of the request response flow. So now, from now onwards in the presentation, I'll be talking of the best practices. I'll be talking about the things you should watch out if you are in the business of creating very similar features within your web apps. As I mentioned, this is a very, very specific functionality, applies to only high volume web applications. So some of those things, going back to the basics, look for what are the various software components, what the overall architecture looks like, what kind of design pattern exists within the code. Because sometimes when the different teams, folks from the different teams, same organization or different organizations, they are working on different parts of the code, things starts falling apart. And then basically it becomes somebody's responsibility actually to bring together everything in place, and by laying out the architecture, by enforcing some principles, and those principles could be around performance, those principles around basically adopting some core principles which have been proven, and Java design patterns are foremost of them. It is so talking about the very first thing. If we look about all these instantiation, means request comes in, lots of objects are initialized, right? It is appropriate to have only one instance of a class, and typically these classes are the objects which are accessed by the disparate objects in a system and therefore require a global point of access. So in our context, as I said, so tracking is one of those objects which is required by anybody. The reason is we want all these requests to log the tracking data using this singleton. So we do use singleton pattern. So that is initialized only once, and not multiple components are using multiple tracking. It's just one tracking class initialized once, and then basically everybody is using that. Once the response is ready, we flush that object and everything is tracked. So moral of the story, if you have a situation where the objects is going to be used or going to be accessed by multiple components, singleton pattern makes sense. Decoupling the sender and receiver of a request by interposing a chain of objects between them. So as we saw, a request is received. This request has to go through several processing stages, and those processing stages could be specific to the core kernel component, could be specific to the application. So how do we do all that? So chain of responsibility, the design pattern, that comes very handy. So chain of responsibility, basically what it does is, it's a source of command objects, and there is a series of processor objects, and each of these processor objects that defines the command that it can handle, or otherwise what it does is it takes and forwards it to the other processors within the chain. So we do use chain of responsibility. Once the request is used, we have components, and each of those components do a very specific responsibility. Building extensible software with pluggable objects by allowing communication with a loosely coupled objects. So that's another challenge. The request is received. Some of those processes, some of those execution which you want to do may be dependent or may be independent on each other. So in case of where there is a dependency, how do you keep these things informed of those dependencies? Or basically, like for example, before you can experiment, tracking has to be initialized. What if the tracking is not initialized successfully? Correct? Experimentation cannot happen because experiment cannot log. So to do all this, observer pattern, which is basically defines a list of observers, and What the observer pattern does is basically there's a notion of subjects, and that subject basically notifies all the observers for all the events basically they care about. And this is primarily used, the observer pattern is used for distributed event mechanism. If you want to do like some distributed event mechanism, you can use observer pattern. So we do use that as part of our request response flow. Software usually at any given company is always a mixture of software packages. Could be from different groups, could be within the same group, even sometimes basically some open source libraries. And at the end, the expectation is everything should work seamless, right? So how do we make all this happen? Some of those things, they can't even work. They need certain transformation. How do we do that transformation? Adapter pattern. So adapters are basically, they let the objects from unrelated packages collaborate by adapting one interface into another. So within all these analytical applications, there is a very strong need of delegating, sequencing, and executing methods at a time of choice and without knowing the honor of the method or the information that's required by the method. So to accomplish that, command pattern comes really handy. So because command pattern, what it does, it uses the object to represent as well as to encapsulate what is required to execute that method at a later point of time. So the command pattern, the way it has three players, what those three players are, there's a client, there's an invoker, and then there's a receiver. So the client is the one basically who instantiate the command and also provide the required info. Invoker decides when that method should be executed, and receiver is the one, basically it's an object that contains the method. So we do use command pattern because command patterns, you can do parallel processing by using command pattern. So if you are looking for implementing thread pool, command pattern is used for implementing thread pool. Proxy. So the proxy, substituting a proxy for an object. So proxy is another very useful pattern that comes handy. And the way we use it is in certain cases, multiple copies of the object, they must exist. And like in our case, so we have like a personalization object, request comes in, all these requests are coming in, the personalization object for each of those requests is kind of different, right? So these objects need to exist, they have to exist together. So the personalization data, all that is coming from some persistent store, and for all that optimization we do have like in memory everything on it, but still for each and every request, some of the things which we could defer, we want to do lazy initialization. So for doing all that, for lazy initialization, we are using the proxy pattern. Another challenge is on those kind of models, when a request comes in, as I said in the beginning, lots of objects are getting initialized, and what it affects is basically it can decrease your application memory footprint and then basically impact the performance of your application. So how do you do that actually? So for this particular one, there's a design pattern which is called flyweight pattern, which works by sharing an existing object. So the example I was giving was like we create this tracking object. So every each of those components which are dependent upon, they are not creating their tracking object. It's the one basically that the tracking object is created and then it's being reused by everybody. So we do make use of the flyweight pattern, and by using the flyweight pattern, basically we do support a large number of objects which are being used efficiently. So think about that, hundreds of millions of requests. Each of those hundreds of millions requests, there's an experimentation, there's a personalization that's happening. And let's assume they are not creating or reusing the single tracking object and they are creating their own. How many objects at hundreds of millions of objects we got reduced by implementing flyweight pattern? Facade, very useful one. All of us are very much into open source libraries. We also use a lot of open source, and sometimes internally some of our historical code which we don't want to touch, where we don't want to take the dependency on that historical code which we don't know actually. Sometimes actually in like big companies like eBay, you don't know actually he owns it. So how do you do that? We use the facade pattern so that we are reducing the complexity, and also we are reducing the dependency on this component basically, which is quite complex. So this was just a brief on the various design patterns that we leverage, that we use, and along with the use cases. Now I will go over the few things actually which anybody should consider who is in a very similar subject area. One of the very important thing, what we call the service decoupling. And as I said, actually, like, time to go back to the basics. When you go and review the overall architecture, look at how the each and individual components been done. Look for or how those components been created. Is it like a monolithic architecture, or it is already broken into components? And some of those components, can you isolate them? Can the processing occur asynchronously? Web services decomposition. So when we talk about the web services, the very first thing, when we talk about very, very low latencies, very, very low response times, and even from like implementation perspective, like your application is dependent on my code, like because we are in the kernel, right? So kernel is kind of because we are the kernel component, and if I do a certain mess up in any of these three applications, guess what? Overall response time is affected. I will immediately get the call from kernel team. Gosh, what did you do? What did you do? Overall response time is affected. eBay is basically has slower down the request of each and response time, right? So the concept of the local binding and the remote binding. So the local binding is request handler. The request comes in. Any subject area specific, like tracking, one handler for tracking, one handler for experimentation, one handler for personalization. Then we have the request response adapter. So the way we have this adapter model here, for any time there is a platform change, like for example, the application server changes, how do I keep myself transparent to all those changes? Adapter pattern. Because at that point, my service is not going to change. Service is already, it's a separate component. I have already done what we call the service decomposition, and running in the local binding. So which means my web service can run on the same JVM where my application is running. So for certain cases where the performance is mission critical, as we are saying, like milliseconds, going remote binding is not an option. The reason is, it depends actually, because once you are into the remote binding model, and with the fault tolerance built into those systems, what if the call goes cross colo? Yes, even like means we do have remote binding as well, local binding for all these service deployment. We do have the service deployed in each colo, and historically, with 95%, all these calls are served by the local colo. But there are instances when my local colo service is down. In those cases, the request gets redirected to the remote colo, and then we are talking about in colo latencies, which can be up to 15 to 20 milliseconds, or maybe more than that. So this is one of the decisions actually you should consider if you are basically some complex logic. Break it into components, create, if it's around the business logic, create some services around it, and with that you will be able to isolate, able to reuse all that code, even when some of those core things may change. So this was local binding. So application server and service with a local Java binding is running in the same application server. This is the example of remote binding, where my web services, basically they are outside of the application server. And in these cases, as I said, there's a performance implication, and proper thought should be given before you make the call that I need to make my service a local bind or a remote bind. Few more things actually you should consider. Always pool the valuable system resources like threads, database connections, socket connections. So this is not something unless you go and look at the code. So when all these mission critical, low response time applications, you need to optimize on those things. You cannot afford to create or initialize the thread on each request. You have to have a thread pool concept. Means you need to use, means otherwise you can't even serve hundreds of millions of requests. Optimize your IO operations by using the buffering when writing to and reading from the file systems of the stream. So this is like it's a caching concept. Minimize the network overheads by retrieving several related IOs simultaneously in one remote invocation is possible. This is more on the how do you implement the business logic. So this is purely for, as I said, so all these things you won't actually know. So these are some of the things which are best practices, which are the things you should consider, but they are purely from code perspective. You need to look at the code. So these are some of the guidelines which I have laid out, and I go and basically try to ensure that when the code review happens, these things are taken care. Evaluate single-threaded versus multi-threaded performance perspective. So there is a misconception. People think actually just make an application multi-threaded, everything will be a smooth sail, and then performance will simply increase. Is that true? I don't think so. It's very, very case specific. So multi-threading may not help. That's why I have the point here. You need to evaluate a single threaded as well as a multi-threaded for your case. It's a very case specific thing. And then based on the outcome, you should decide that whether to go for a single threaded or multi-threaded. Don't go by your gut feeling that yes, multi-threaded works. Believe me, we have multi-threaded implementation, means a lot in our application, but it's not that all our application is working in a multi-threaded mode. No, that's not a true statement. Yeah, there's a lot of challenges with implementation of multi-threaded context. Serialization and deserialization, another thing, very important. So what is it all about? So we talked about decomposition, we talked about layers. So when you look at the overall architecture, so you need to go and overview how many times objects will be serialized and deserialized. The more hops you add into that flow, like for example, as part of your request response flow, more serialization and deserialization. Each serialization to deserialization costs you like 2 to 3 milliseconds. Additional cost. So all the mission critical applications where even 0.05 millisecond counts, serialization, deserialization, how many times you do becomes an important factor. CPU profiling, memory profiling, some of those things you need to do it. You can't launch an application in a production without doing basically any CPU profiling or any memory profiling and assume everything is going to smooth sail. No, you will have issues. So these are some of those applications where you have to have your application CPU profile as well as memory profile before you actually release it to the production. And how do you test these things? Means you take the server out, means in the live traffic, I'm saying in the live production traffic, take one server out of the traffic, profile your applications on the live traffic just on one machine, and see basically is application is performing within the promised thresholds. So that's all I had for my discussion. So I hope everybody enjoyed it, and thanks for your time. So we have 5 minutes for any questions you have. Yes. JProbe. Anything else? Yes. So the question is, do we have rigorous processes built around it to monitor everything? So yes. Yes. So what we call that is a continuous integration. So so every time we make the changes to any of these core kernel components, we have basically the CI processes which run on continuous builds, and we Jenkins. Yes. Mm-hmm. No. I'm not talking about. I'm talking about one object per request. No. So it's a manager that is invoked once. Okay. Pardon? Not within these applications. So the question is, do we use method oriented architecture? Not within these application context. Yes. Question is, which application server is being used for these applications? So eBay runs on custom application servers. We are not using any off the shelf. It's all custom. That's why we have full control basically on the software stack. Yes, we are using our own application server.